Hello, my name is Terje Vernly. I'm a senior technologist in Pexip, and today I'm going to talk about how Pexip is considering using server-side AI to enhance video conferencing. And by server-side, we mean doing it in the infrastructure and not in the devices that are connecting to a video conference. I have roughly 25 years of experience in the video conferencing industry, starting out mid-90s as a protocol programmer in various EU-funded projects experimenting with video conferencing over the internet for distance education purposes. I then moved on to Tamberg as a senior technologist there, working with standardization and protocols for both H323 and SIP. And then I continued as a principal engineer in Cisco with various other projects, including technical alliances, and now I'm in Pexip. Here at Pexip, we have mapped the top 5 user concerns for video conference users. 1 is lack of confidence in appearance. 2, dog barking and other distractions. 3, doorbell or delivery. 4, mute button issues. And 5, distraction from children. Pexip is currently researching how to use AI technologies such as natural language processing, avatars, noise reduction, room echo cancellation, gaze correction, and many more exciting technologies, and we're looking at how they can enhance video conferencing. Today I'm going to talk about the 3 highlighted items. Basically, noise reduction, room echo cancellation, and gaze correction, which are 3 major issues in the video conferencing industry. Primary research team that has been working on evaluating these AI technologies are Håvard Graff. He's a principal engineer in Pexip. He likes to call himself a media guru. And also Knut Inge Hvitsten is a software engineer, and he's specializing in signal processing, both for audio and for video. Meet Pexip. So who are we? What do we do? So I'm going to talk a little bit about where we come from and our components that make us unique in the industry, and then we'll continue diving into the AI technologies. Pexip was founded in 2011. Today, we are roughly 500 employees in 23 countries, more than 300 partners in 75 countries, over 3,600 customers worldwide, 190 countries with active users, and we are proud to say that we have a net customer retention rate of 115%. We are also listed on the Oslo Stock Exchange in Norway. Ranked number 1 overall in 2019 by leading industry researchers by Wainhouse. Pexip. So what do? Well, our mission is to empower people to be seen and to engage with each other in a better way. Our vision is to make virtual meetings better than meeting in person. Our promise: meet the world with video communication as it should be. I'm going to talk about Pexip Infinity technology stacks. Everything we do in the infrastructure to facilitate video conferencing. So many of you are most likely engaged in video meetings at least on a weekly basis. It may seem easy. You are just clicking a link and appearing in a browser and everything looks to be automatic, or you're dialing a SIP URI and enter a conference, and it may seem easy. But on the back end of this, it's a highly complex set of components that facilitate the video conferencing that you are using. So in Pexip, we have 4 major components that build the video conferencing infrastructure. The management node is basically the heart of the infrastructure. It takes care of all the configuration. It takes care of logging. It takes care of upgrading the other components. It takes care of watching the ongoing conferences and giving you stats about previous usage. And then we have the conference node. This is the heavy lifter in the technology stack. It does all the decoding and encoding of audio and video streams from all the participants, tie them into a virtual meeting room, as well as talking to the other conferencing nodes in that environment in order to cascade conference, if you like, meaning having a single conference span across multiple conferencing nodes. Then we have the edge node. This is a node that sits in the customer DMC and basically shields the two other nodes from attack from the internet, only letting through the necessary traffic to facilitate video conferencing, like SIP, 323, WebRTC, and then of course also RTP and SRTP, which are the protocols for transporting media over UDP. And then we have the Teams connector node, which allows any standards-based video system, be it SIP 323 or WebRTC, to call into a Microsoft Teams meeting and be a participant on equal terms as the Teams participants on PC clients or Microsoft Teams rooms from Microsoft. Customers can choose to deploy these conferencing nodes and management nodes and edge nodes and connector nodes in 3 different ways. First way is to deploy them in their own private cloud or on their own bare metal servers in their own data centers. Second way of doing it is to use Pexip Private Cloud, where we handle all the conferencing nodes and you just handle the management node. And we make sure that no other companies can actually call into your conferencing infrastructure. And then there is the Pexip public service, where we manage everything and customer just pays for a monthly subscription and all the services he would like to use. And then we will handle calling, we will handle conferencing, and we will handle calls to Teams and Google Meet. Pexip Infinity is highly distributable and scalable. So what I'm showing here is a typical view into a virtual meeting room hosted by Pexip. So most of these frames are using Pexip technology that we call adaptive composition. It includes face detection, and then we frame and count the number of people in the room, and then we crop and scale the image accordingly so that only the important parts of the meeting room are distributed to the other participants. This conference can host both WebRTC, SIP, and H323. Here is a very scaled down illustration of the conference of the previous page. So here there are just 3 participants, one in Frankfurt, one in Ashburn, and one in Amsterdam. These conference nodes all talk together, making sure that they distribute the necessary video streams between them, and the devices that are connecting to the closest conference node to achieve as low latency as possible. All our media pipelines are built on GStreamer. That means that it's very easy to plug in new processing components in both the audio pipelines and the video pipelines. Here I'm showing a typical audio pipeline from a participant dialing in to a conference node. It shows the path all the way from the UDP socket, all through the decryption to the jitter buffer, to the decoder, and then we convert everything to 48 kilohertz 32-bit float. Reason for converting to 48 kilohertz 32-bit float is that it's a very nice format to have internally. The reason for that is that it has far greater dynamic range than any of the audio codecs used in the video conferencing world today, and also greater dynamics than the typical AD and DA converters that are readily available. And also, maintaining a float pipeline is much easier for the developers than maintaining a fixed point pipeline. So also today in Intel's architecture and also AMD, float operations are highly optimized. So it's a very effective way of handling audio internally. And also when there are new audio codecs coming out to the market and being implemented by WebRTC, then we don't have to change our internal format because it's already ready to handle the dynamic range of the new protocol. So what can Pexip do with Nvidia AI to enhance the Pexip meeting experience? Video conferencing and conference in general have some weak points that have existed since the beginning, and no one has really solved them. Background noise, also known as please mute your microphone because the other participants are irritated by noise you are sending through the microphone. Poor acoustics in the meeting room, causing unwanted reverberation and thereby reducing intelligibility, and also lack of eye contact. So, how does Pexip intend to solve these issues? Nvidia Maxine AudioFX SDK has a feature called noise reduction, which removes a list of noises that don't belong in meetings, like AC noise, PC noise, chatter from other people, typing noises, fan noises, sirens of passing police cars and ambulances, tapping of pencils on the table, dog or other pet sounds, and as well as many other annoying sounds. And it does this with a 30 milliseconds latency, which is acceptable given the huge benefits of these technologies. As we looked at a couple of slides back, our audio pipeline is three-streamer based. So all we have to do to include a new component into the pipeline is basically, as I'm showing below, the NVAFX, and we pointed to a model that we're interested in using. In this case, the denoiser 48 kilohertz. That does the noise reduction for us, and then the audio pipeline continues as normal without this plugin. So we have had some issues with the scalability using this plugin. So in the beginning, we were using it in a way where we could only get a limited number of concurrent audio processing streams, and that was at a point where this would not be economically viable. But right now, we are working with Nvidia for a next generation plugin where we can bring this to a level of scalability where it becomes economically viable. So to illustrate what Nvidia AI noise reduction can do, I recorded a file and then processed it. So on the top, the two graphs there contains the intensity of the contents of the audio files. And then the bottom graphs shows the spectrum analysis. So as you see on the top left, which is the intensity, there is continuous noise, whereas on the top right, there's actually gaps between, indicating that something has been removed. If it's supposed to be there or not, we don't know until we listen. But the spectrograms look very promising. You see a lot of high frequency noise in the input on the left bottom, and there's less high frequency in the output. So this looks very promising. Let's play these and see if the Nvidia noise reduction has done its job. This is a test of my very noisy gaming keyboard while I am talking, just to see what the Nvidia denoiser can do to this very irritating typing noise. So yeah, that's a very noisy gaming keyboard. And here is the output. This is a test of my very noisy gaming keyboard while I am talking, just to see what the Nvidia denoiser can do to this very irritating typing noise. And we think the result is very impressive. In fact, it's too impressive. So for a pure audio conference, I think sort of removing all the noise is acceptable and probably preferable, because you don't have a visual indication that noise is being introduced. But for a video conference, where you might actually have visual cues to noise being injected, it may seem odd that if the far end tears a piece of paper and you don't hear a single thing, you may actually think there's something wrong with the microphone on the far end or the speaker system on your end. So what we've done in Pexip is to tune this. So the SDK has an intensity ratio that can be tuned all the way from 0.0 to 1.0, where 1.0 removes everything and 0 removes nothing. So we did some blind tests internally in Pexip, And we've landed on a value for the intensity ratio of 0.85. We think that's a good trade-off between some noise being injected into the conference, but it's not at a point where it's disturbing. And we think that's the way to go, but this will require continuous tuning. There's a fun story here. So when I was demoing this prototype for our chairman of the board, Michel Sagen, the gardener walked outside my apartment while we were talking with a leaf blower. And Michel didn't hear a thing, but I was kind of embarrassed because I didn't think the AI noise removal was that effective. But when I asked Michel, he said he didn't hear a thing. What I started this presentation with was server side. And that's the key here. So we're doing this server side, meaning in the infrastructure, in the backend, where all the clients are connecting to. Meaning no matter what endpoint you dial in with, if it's a PC, if it's a Mac, if it's an Android phone, if it's a iPhone tablet or a video conference system of your choice, then we will do this noise reduction in the cloud, in the infrastructure, so that you get the benefits no matter what system you have in the conference. Now we're going to look at the second item on the list on the first slide, and that is poor room acoustics that cause room echo or room reverberation, as it's called in the audio world. So modern meeting rooms may look nice, but the way they are constructed may not be good for acoustics. They have many flat surfaces like windows to the adjacent meeting rooms or halls. They have flat floors, they have flat walls, and they have flat ceilings. All of these things combined is not good for acoustics. The sound from my mouth will bounce off the table and then hit the wall, the ceiling, and then might actually hit the microphone a second time or a third time. This greatly reduces intelligibility. The normal solution to this is to treat the meeting room with expensive sound deadening material, but we've chosen to look at how AI can actually help us, and looking at the Maxine room echo cancellation model. So what I've done here is to record an audio stream in a room with very high reverberation, pass it through the Maxine AI, and then we have the input on the left and the output on the right. Same as the previous graphs, we now see the intensity at the top and the spectrogram at the bottom. Here there is no clear picture of what we've actually removed. We see that we have removed something, but we cannot be absolutely sure what we have removed unless we listen to it. So we plotted this in a different way. So this is the energy in the audio signal. The blue is before passing it into the Maxine room echo cancellation AI, and the red graph is after passing it through the AI. So what we're seeing here is that the energy in the red plot drops off more rapidly after the speech impulse than the blue plot. So I'm going to play a couple of snippets so that you can hear what I'm talking about. So this is the input. 1, 2, 3. This is an example of a room with very poor acoustic properties for video conferencing or conferencing in general. So what we heard there was a room with very poor acoustic properties, and you would not believe that could be used for a conferencing activity in a professional environment. So here is the output. 1, 2, 3. This is an example of a room with very poor acoustic properties for video conferencing or conferencing in general. Quite impressive, isn't it? So again, like we did with the Nvidia noise reduction, we just include another GStreamer component into our pipeline. In this case, we're passing it a different model. It's the D-Reverb 48 kilohertz model, and then we're just continuing the pipeline as we did before. So this does the job. We're now removing echo from the local room, but now we're adding another 30 milliseconds worth of latency to the pipeline, because we now have two AI models into the pipeline. We have the noise reduction and we have the room echo cancellation. So Nvidia have thought of that. So they have included a model that does both of these AI technologies in one go. So here is the example, GStream pipeline just being passed a different model, the de-reverb, denoiser at 48 kilohertz. So now we're doing both technologies at once. And now we come to the third item on the list, lack of eye contact. Because the angle between the center of the screen and the camera is quite large, it is very difficult, if not impossible, to create proper eye contact. And as screens get taller, the angle gets even larger and the problem gets bigger. So in the professional world, like news anchors, they use a device called a teleprompter, which is basically a camera sitting behind a semi-reflective mirror. So when the user looks into the camera lens, the mirror reflects down to the object the user is going to look at, and it creates almost perfect eye contact. But it's not very natural, and it requires a lot of training to get correct, and would not really work in a meeting room scenario. So in Pexip, we would much rather achieve eye contact using server-side AI, so that we can offer proper eye contact to all devices, no matter what. So this is to illustrate lack of eye contact. Here is a setup at home where I have a video conferencing system. It's a camera on top of a quite large monitor. And here's the very noisy keyboard, by the way, that you heard in the noise reduction slide earlier on. So here you see that when I'm looking at the center of the screen here, the angle between the center of the screen and the camera is probably around 20 degrees, which is quite a lot. And the participants on the other side of this conference may think that I'm not paying attention and that I'm doing something else because I'm not looking at them through the camera. So this is from the camera showing that it looks like I'm doing something completely else. I'm looking almost straight down. It doesn't look like I'm interested in this video conference at all. So then we pass this into the Maxine AI gaze correction algorithm, and it detects my facial features. You see, it detects my eyes, my mouth, and then it tries to calculate the direction of my face. And the red arrow points to where I'm looking at, and then the AI corrects for this, and my eyes is now looking at the camera, even though I'm looking at a completely different point. So we think this is amazing technology, and we are looking at ways to incorporate this into our solution. So, to summarize, the research work in Pexip has looked at AI technologies for addressing background noise, room reverberation, and lack of eye contact. Right now, we have a research prototype for noise reduction and room echo cancellation, and it's at a proof of concept stage. So it's not to be productized as of now. It's purely a research project. As for gaze correction, this requires more work, but the research results are very promising, so we are looking into how this can be incorporated. Interested in more information? For questions to the presenter, please use the chat and I will respond as soon as possible. If you would like to know more about Pexip and what Pexip offers, please go to pexip.com and contact us if you have questions. Thank you very much. Hope you enjoyed this and enjoy the rest of the Nvidia GTC conference.